In continuation to my previous video lecture, today I will be discussing PDA definition and also how to represent the PDA. So it has following tuples. Q is a set of finite state, sigma is a set of input alphabet. So these two tuples are same as finite automata, and this is the symbol used to represent the stack alphabet. And delta is a transition function which is a mapping from Q into sigma union epsilon. So in last video lecture, I have discussed already what is the transition, what will be the transition function. So transition function will take three parameters, delta, this will be the current state, and then input alphabet, and then stack top, suppose if it is Z0. So here we will get the next state, suppose it is Q1, and if I say AZ0, so this is the stack content. So here first parameter is going to come from Q, second will be input alphabet from sigma, and the second parameter can be epsilon also, because a PDA will be a non-deterministic finite automata plus stack. So this epsilon will also come, and then here Z0, this will, the third parameter will be the stack top. So this symbol is used to represent the stack alphabet. So this will be this symbol, and then here we are going to get again some state, so it will come from Q only, and then this will be the stack content, so it will be stack alphabet. This symbol we will put star here. Okay, so that's how we have got this transition function. And then Q0, as Q0 will be the start state like finite automata, F will be the final state, and this Z0 will be, it belongs to this symbol stack alphabet only, and it will be the initial symbol onto the stack. Okay, so these are the tuples for PDA. Now here if the transition function, you can see here these are the three parameters. So what action will be performed by the PDA? It depends on the three things, right? So if I say I have a transition function, and this is the state, input alphabet, and the stack symbol, stack top basically, and if this is the state, and here if I say AZ0, so that means A is pushed onto the stack. So the action performed by the PDA, it depends on three things: the current state, okay, so current state is nothing but this, and then the next input symbol. So the second parameter of the transition function is the next input symbol, and then the third parameter is the symbol on the top of the stack. So this is the symbol on top of the stack. So these are the things, the action performed by the PDA. So the action performed by PDA, so it depends on these three things. And the action performed by the machine, it consists of, so after this you get either changing the state from one state to another state. So machine was in state Q0, and the machine state is changed to Q1 now. So then you get changing the state from one state to another state, and then this is the stack content. So then you will say replacing the symbol on the stack. So this is the action performed by the machine, consists of these two things. Okay, so in general we will say the transition function accepts three parameters, namely a state, and then input symbol, and the stack symbol, and it returns a new state after changing the top of the stack. That is, the transition function has this form. So you can say a delta, in general you can say you will be having state here, and then input symbol is the second parameter, and then stack symbol is the third parameter, and then you get next state of the machine, and then stack symbol. So this is how a transition function should be defined for PDA. Okay, so now there are two ways to represent a PDA, a transition function notation or the graphical representation. So two ways are a transition function, that means delta, using delta notation. So PDA representation, you can say. So first one is that, and the second one is using graphical representation. So when we have to construct a PDA, we can either give a delta notation representation or we can give the graphical representation. Okay, so now delta representation is this one, like we'll be writing three tuples, the state, the input given to the machine, and then the stack top, and then what will be the next state of the machine and what will be the stack content. So this is how we will be giving the first way of representing the PDA. Second way is using graphical representation. So how do we give the graphical representation for the delta notation? We will see now. So here the state of the PDA correspond to the nodes in a graph. Okay, so state of the PDA will be nodes, and the start state of the PDA is denoted by an arrow labeled start. So this is how we will represent the start state of the, so this will be the start state of PDA, and then a final state, the node of the graph represented by two concentric circles are the final state of the PDA. So we will be having final state like this. So this will be the final state of PDA. And then if there is a transition, if I say there is a transition in this form, if I say P is the current state, A is the input, Z is the stack top, and then Q is the next state, and then AZ is the stack content. Okay, suppose this is the state P. So now the same thing, this is the delta notation. How do we represent it? Using graphical representation. So let's say P is the start state and there is another state Q, and the meaning is here if I give input A and the stack top is Z, okay, and the what action we are going to perform? We are going to push A onto the stack. So we write A Z. So like this we will be representing. Okay, and for example, if I say we have delta P epsilon Z, so that means we are not reading any input. Epsilon means no input, Z is the top of the stack, and Q epsilon, that means this when we write epsilon here, that means it represents pop operation. So here how will we represent it? We will be, this P is the first state and Q is the current state, we can say Q is the next state, and then here if I give epsilon and the stack content is Z, what operation we are going to perform? We are going to pop, so epsilon. So if we have delta notation, we can write the corresponding graphical representation. So this is how we will be representing the PDA, and when we draw the final DFA, so we'll be having some intermediate state. So like the way we have represented in finite automata, the start state, and we had intermediate state and final state. So start state will be represented using this start label arrow, and the final state will be represented by two concentric circle, and other than start and final, this whatever states we will be having, that will be intermediate state. So this is how we give the representation of PDA. So hope you have understood the concept. Thank you for watching.